Hey everybody, so in this video we're going to talk about section 4.3, which is curve fitting. Okay, so the idea of curve fitting is to model data using an equation. Okay, and we do that by writing an equation that goes through given points. Okay, so later on we'll look at some examples of using actual data to model something. Okay, but for now we're just going to go through a couple of examples where it's obvious how you should write this equation. Okay, so for this section we're only going to talk about modeling using quadratic equations, but you can model using lots of different types of equations. Okay, all right. Okay, so we're going to start out with this example. So you can see that in this example, they're actually giving us the vertex here. Okay, so it says the vertex is this. Okay, so because we have the vertex, we're going to use the vertex form. Okay, so remember that's a times x minus h squared plus k. Okay, and the first thing we're going to do is fill in the vertex hk. Okay, so let's do that now. Okay, so this looks pretty good already, right? We really only have one thing left that we need to fill in, and that's where this second point comes in. Okay, so we're going to plug in our second point for x and y to help us figure out what a is. Okay, so we'll plug in 80 for y, okay, and 20 for x. Okay, and again, we're only doing this because we want to figure out what a is here. Okay, so 20 minus 30 is negative 10. Okay. So negative 10 squared is 100. Okay, now we have a linear equation that we can solve for a. So we'll subtract 280 from both sides. Okay, and then we'll divide both sides by 100. Okay. So now that we have our value of a, we can go back here where we almost had our equation done and fill in the value that we found for a, which was negative 2. Okay, so we'll have y equals negative 2 times x minus 30 squared plus 280. Okay, so for these, right, you're writing a quadratic equation, so your answer should always be an equation like this, okay? Sometimes students get confused and think they're solving for a, right? But your final answer is the equation, and in this case, it's in the vertex form, right? So here's my vertex, and then we solve for a using that second point that we were given. Okay. So when you have the vertex, that's a lot of information about a parabola. Okay, so in that case, we only needed 2 points. Most of the time, we're going to need 3 points, okay? So let's look at another type of example. Okay, so we're going to write the equation for a parabola with given x-intercepts, and those x-intercepts are going to be 2, 0, and -3, 0. Okay. Okay, and it additionally passes through the point 0, -12. Okay. So we have these 2 x-intercepts, okay, and then we have a third point, 0, -12. Okay, this happens to be the y-intercept, but that's actually not important for this example. Okay, so because we have the x-intercepts, remember how you get the x-intercepts, right? You get the x-intercepts from the factored form. Okay. So we're going to look at the factored form, right, that looks like this. Okay. And we know that the x-intercepts are what's in these factors, right? We've seen that a ton by finding the x-intercepts when we're graphing, okay? So we're going to fill in the information that we get from our x-intercepts. So I'll have x minus 2 and x plus 3. Okay, so most of the form here is coming from the fact that we know the x-intercepts. Okay, now we're going to solve for a using our additional point. Okay, so you guys can see that that's kind of a theme, right? Either the vertex or the x-intercepts is giving you most of your information, okay, and then you're using your extra point to fill in that value for a. Okay, so we'll put, we're filling in this for x and y. Okay, so we'll get -12 equals a times 0 minus 2, 0 plus 3. Okay, so 0 minus 2 is -2. 0 plus 3 is 3. Okay, so this is giving me -6a. Okay, and I can solve this by dividing both sides by -6. Okay, so now that I have my value of a, I can plug it into this equation. So I have 2 times x minus 2 times x plus 3. Right? One factor corresponds to each x-intercept, and I use my extra point to find the value for a. So this would be my final answer. Okay. All right. Let's look at another type of example. Okay, so those are kind of special cases where you know the vertex or you know the x-intercepts. Those points are somehow more important than random points. Okay, but what if you do only know random points? Okay. So before we started, when we had the vertex, we started with vertex form. We had the x-intercepts, we started with the factored form. Okay. we don't really know anything about these points or where they lie on the graph, so we're just going to start with the standard form, the ax squared plus bx plus c form. Okay, we have no reason to start with another form. We don't know the vertex. One of these points could be the vertex, but we don't know. So we don't know the vertex, okay? We don't know the x-intercepts. We can be sure that none of these are an x-intercept because none of them have 0 as the y-coordinate, okay? So all we're going to do is plug in each of these points, okay? So we're going to plug in the first point 1, comma 11, okay? So that will give me 11 equals a times 1 squared plus b times 1 plus c, okay? And I'm going to write this in a specific format, okay? So I would get a plus b plus c equals 11. Okay, then I'm going to do the same thing with the next point. Okay, so I'm going to plug in negative 1 comma 17. Okay, so I'll have 17 equals a times negative 1 squared plus b times negative 1 plus c. Okay, and again I'm going to write this in that other format. So negative 1 squared is 1, so I'll have 1a minus b plus c equals 17. Okay, and then I'm going to plug in my last point, which is 337. Okay, so I have 37 equals a times 3 squared plus b times 3 plus c. Okay, so I'm going to write this in that form again. 3 squared is 9, so I get 9a plus 3b plus c equals 37. Okay, now I'm going to gather these equations together so that we can look at what they all look like. Okay, so I have a plus b plus c equals 11. Okay, then my second one was a minus b plus c equals 17. And my third one was 9a plus 3b plus c equals 37. Okay. So this should look familiar to you. Okay, this is a system of 3 equations. With 3 variables. Okay, and we studied this in chapter 2. Okay, so we are going to use Gaussian reduction. Okay, to solve for a, b, and c. All right, so let's look at that. Okay, so when we're doing Gaussian reduction, we want to look at the set of equations which is here, okay, and we're going to say what variable we're going to eliminate. Okay, so you can see the b's are already set up for elimination. Okay, I'm going to number my equations here. Okay, so I'm going to use equation 1 and 2, and I'm going to eliminate b. Okay. Okay, so this is my plan. Okay, so I'm just going to add them together. So I have a plus b plus c equals 11, and then I have a minus b plus c equals 17. Okay, so I'm going to add them together. I get 2a, those cancel as intended, plus 2c equals 28. Okay, and this is my equation 4. Okay, so now my next step is I need to eliminate the same variable, okay, in 2 different equations. So I'm going to look at my equations again, okay, so I can't use 1 and 2 because I already used that pair. So I can either use 1 and 3 or 2 and 3, okay, so I'm going to use 2 and 3. So I'm going to take equation 2 and 3, okay, and I'm going to multiply it by 3, okay, so that the b's will cancel out. So I'll get 3a minus 3b plus 3c equals 17 times 3. Okay, so I'll just do 17 times 3, and I get 51. Okay, and then I'm just going to copy my third equation. Okay, so that was 9a plus 3b plus c equals 37. Okay, so now I'm going to add these together. So 9 plus 3 is 12a. These cancel, which is what we wanted. Okay, I get 4c. And then 51 plus 37 is 88. Okay. All right, and this is my equation 5. Okay, so I just want to write down the new equations that we have. Okay, so I have 2a plus 2c equals 28. Okay, and then I have 12a plus 4c equals 88. Okay, so if I'm going to use elimination, I'm just going to multiply this top one by -2. Okay, so that will give me -4a, -4c equals 2 times 28, right? Which is 56. Okay. And then I'm going to just copy this one over. So I have 12a plus 4c equals 88. Okay, and now I can add them together. So -4a plus 12a is 8a. These two cancel as intended. Okay, and -56 plus 88, okay, is 32. All right, so now I'm going to divide both sides by 8, and I get a equals 4. Okay, so I'm going to plug back into this equation. Okay, to solve for c. Okay, so this gives me 8. Okay, subtract 8 from both sides. So c is 10. Okay, and now I have my value for a and c. I'm going to have to plug into one of my original equations, okay, to solve for b. Okay, so I'm going to look for b. Okay, so remember one of my original equations was a plus b plus c equals 11. Okay, and I'm going to plug in my value for a and my value for c. Okay, so I get c equals -3. Okay, all right, so that allows me to write my equation. Remember, you're not just solving randomly for a, b, and c. We were in this situation. Okay, so we're going to fill in our values for a, b, and c. Okay, so a was 4. Okay, b was -3, and c was 10. Okay, so this is the equation of the quadratic formula that goes through those 3 given parts. Okay, so that is another application, by the way, of the Gaussian reduction method that we learned in the last chapter. Okay. All right, let's look at our last example where we actually use some data points, okay, and we write a model, okay? So the following data shows bike rentals in various years, okay? We're going to assume from like a single shop, okay? So the first column is years, or the first row is years, and the second row is number of rentals. Okay, so it shows 2000 all the way to 2004. Okay. Part A says write the data from 2001, 2002, and 2003 as ordered pairs TR, where T is the years since 2000 and R is the number of rentals. Okay, so we're going to be looking specifically at these 3. Okay, So T is the years since 2000. Okay, so if we focus on this in 2001, okay, how many years has it been since 2000? Well, it's only been 1 year, okay, and then the number of rentals is 82. Okay, in 2002, how many years has it been since 2000? Well, it's been 2 years, okay, and then we'll look at the number of rentals. It's 194. Okay, and then in 2003, okay, it's been 3 years since 2000, and we'll look at the number of rentals. We have 446. Okay, so now we have these 3 ordered pairs, just like we did in the previous example. Okay, so now we're going to use those 3 data points to fit a quadratic equation, right? So this is a different way of asking us to write a quadratic equation that goes through these points. Okay, so that's what we're doing here. We're writing a quadratic equation that goes through these points. Okay. All right. So just like the previous example, we're going to plug in each one of these, okay? And each one will give us an equation, okay? So we're going to plug in the first point, which is 182, okay? And remember, we're plugging them all into the standard form, y equals ax squared plus bx plus c. Okay, so for 182, we'll get 82 equals a times 1 squared plus b times 1 plus c. Okay, so I can rewrite that as a plus b plus c equals 82. Okay, now I'm going to plug in my second point, which is 194. Okay, so I'll get 194 equals a times 2 squared plus b times 2 plus c. Okay, and I can write that as 4a plus 2b plus c equals 194. Okay, and then I'm going to plug in that last point. Okay, so my last point was 446. Okay, so I would have 446 equals a times 3 squared plus b times 3, okay, plus c. Okay, and I can rewrite this as 9a plus 3b plus c equals 446. Okay, so now I'm going to gather all of my equations together. Okay, so I had a plus b plus c equals 82. Okay, then I had 4a plus 2b plus c equals 194. Okay, and then I had 9a plus 3b plus c equals 446. Okay, so I'm just going to number my equations. Okay, so because the only one with coefficients where they're all like the same is c, I think that one is going to be the easiest one to eliminate. Okay, so my choice is to eliminate c. Okay, and I'm going to do that in 2 pairs of equations. Okay, so first I'll just do it in 1 and 2. Okay, so I'm going to do 1 times -1, so that will give me minus a minus b minus c equals -82. Okay, and then I'm just going to copy my second equation. So 4a plus 2b plus c equals 194. Okay, and I'll add them together. So -a plus 4a is 3a. Okay, Negative b plus 2b is 1b. Okay, those cancel as intended. Okay. And negative 82 plus 194 is 112. Okay. All right. So now I have to pick a different pair of equations to eliminate c. So I'll just pick 1 and 3. It really doesn't matter if you pick 2 and 3 or 1 and 3. Okay. So I'll just do the first equation times negative 1 again. So I'll have negative a, negative b, negative c is negative 82. Okay. And then I'll just copy my third equation. So this was 9a plus 3b plus c equals 446. Okay. So negative a plus 9a is 8a. Okay. Negative b plus 3b is 2b. Those cancel as intended. Okay. And negative 82 plus 446 is 364. Okay. So now I'm just going to write those two equations next to each other, okay, so that I have a nice set of equations that I'm working on, okay. So right now I have 3a plus b is 112, okay. This is my equation 4. Okay, and then I have my equation 5, which is 8a plus 2b equals 364. Okay, so to cancel my b's, I'm just going to multiply the top equation by negative 2. Okay, so this gives me negative 6a minus 2b equals negative 224. Okay, and then I'm just going to copy my second equation. So 8a plus 2b equals 364. Okay, and now I'm going to add them together. So negative 6a plus 8a is 2a. These cancel as intended, right? And negative 224, okay, plus 364 is 140. Okay, I'll divide both by 2. Okay, I get 70. Okay. So now I'm going to use my a value and one of these two equations to find my b value. Okay, so I'll have 3 times a plus b is 112. Okay, so this is 210 plus b equals 112. Subtract 210 from both sides, and I get negative 98. Okay. And now I have to use one of my original equations that have all 3 variables to figure out the last value. Okay, so I had a plus b plus c is equal to 82. Okay, and I'm going to plug in my a and b values. Okay. Okay, so I get 70 minus 98, or negative 28, plus c equals 82. Okay, add 28 to both sides, and I get c equals 110. Okay, so my final equation would be 70x squared minus 98x plus 110. Okay. Don't get distracted by all of the work that you're doing to find a, b, and c. Your final goal is to write an equation that looks like ax squared plus bx plus c. Okay. All right, now believe it or not, this question actually has a part C, so let's look at that. Okay, and it says, what does your equation predict for 2004? Okay, so our equation was this. Oops, we used the wrong variables. We were using t and r, I'm sorry. So So R equals 70t squared minus 98t plus 110. We want to use the variables given in the question. Okay, so let's write that down. I had 70t squared minus 98t, okay, plus 110. Okay, and I want to see what the prediction is for 2004. So in 2004, okay, I know that t is equal to 4, because remember, this is how many years since 2000. So in 2004, t is 4. Okay, so I'm going to plug in t equals 4. Okay, so 4 squared is 16. Okay, now I'm going to do my multiplication step. So 70 times 16 is 1,120. 98 times 4 is 392. Okay, add them all together. I get 838. Okay, so our model predicts 838 rentals in 2004. Okay, now if you look, okay, the real number of rentals was 726. Okay, so our model is predicting a similar number of rentals, but not exactly the number. And that should be the case with a model, right? It should be close to the real data points, okay, but it probably won't be exact. Okay. All right. Let me know if you guys have any questions, and I will see you guys soon.